I come across this video by Scientifically, and it shows a small scale dome of water from a magnetic field. The research in the cause of the ME has led me to investigating the firmament, with me coming across some disturbing evidence. But first I'm going to show how it is possible for a dome to be made from water by Scientifically. All we need to do is scale it up to the size of a dome.
Now I'm going to have to take water out to show you the field that is there. I think we can actually see it. So I'll probably end up taking at least 3 out of this. There's one full one. That's 2. That's 3. And we can see the field there. And those dots that were on it, which is like a concentration pinch point of the field. It's actually where the field has a dome. I'm just going to walk away for a bit. Nope, that's got some crap on it. Alright, that looks like it might be okay. Yeah, no, damn it. Alright, can't use it, I don't want to use that. Oh, that's right, I'm going to use this, I think. Yes, I was. Need that. Something to hold it up. Maybe. Alright. Move that out of the way, yep. Back in the way. Yep. Let's take water out. Those are just 2 pieces of marble that I've put in there. Oh yes, I'm not. There's the magnet, so it's a good eighth of an inch below the waterline. So now that goes, so I can see it. Just come looking for the line. Where's the line? Pull that off the line. When you pull the line. This way a bit more light. Just don't know if I've got the right light in. Oh, there's lighting of some sort. Alright. Well, that's it then. Let's point it later. Alright, so let's take some more water out because I know there's a lot in here. So that's another one of them. Let's feel where it is. Okay, still an 8th, so we'll put another lid out. about a millimetre. Alright, I'll leave that and see if a dome appears in the middle, because them rings on the outside are raised, so it's already bulging at the very far edges.
Just to let you know that Scientific Lee does not believe in the flat earth because he believes he knows everything, so he has closed his mind to new info, but he does have some good info to give, so he is worth subscribing to. This is just a little something extra that made me piss myself.
I remember this.
That's what I'm saying.
I remember this
That's
tweet.
what I'm saying. So I'm there and I'm saying, wait, the angle of this, how long is it? So I checked the stadium on its configuration, what's longitude and latitude, and I said, I did a quick calculation, and I tweeted. The winning field goal in that game was aided by a 1/3 of an inch deflection to the right from Earth's rotation.
Now I call him a whopper, but before flat earth I would have lapped that up by believing it. So we all fell victim to it. Anyway, that's enough fun for one day. I'm now going to show a little bit of footage from my previous video. Did you know stars can now be created in a lab? It's called Sono-luminescence, star in a jar. Let's have a quick look at this being done.
It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star.
I want you to take another look at the bubble before it implodes. This next bit of footage is me taking a picture and changing the colours to see what else is there. Check out what I found. This next bit is footage of the 2015 total eclipse taken from a plane.
15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Viel Spaß!
They look like bubbles to me. What do you think? I believe the firmament is voltage flowing through water, and I am going to show you supporting evidence for that. You just need to think about scaling things up to the size of the dome.
Now here's another example of walking on water. This is a lizard from the Central America, and because it walks on water, it's called the Jesus Christ lizard. And of course, you'll say, well, I know the answer to this. The surface tension is high on water, but the common idea of surface tension is that there's a single molecular layer of water at the top, and this single molecular layer is sufficient to create enough tension to hold whatever you put there. I think this is an example that doesn't fit that. And here's another example, 2 beakers of water. You put 2 electrodes in, and you put high voltage between them, and then what happens is a bridge forms, and this bridge is made of water, a bridge of water, and this bridge can be sustained as you move one beaker away from the other beaker as much as 4 centimeters, sustained essentially indefinitely. How come we don't understand this? So what I mean is that there are lots of things about water that we should understand, but we don't understand, and so we really don't know. No. Also, the phases of water. Now, we've all learned that there's a solid phase, a liquid phase, and a vapor phase. However, 100 years ago, there was some idea that there might be a 4th phase somewhere in between a solid and a liquid. Sir William Hardy, a famous physical chemist, 100 years ago exactly, professed that there was actually a 4th phase of water, and this water was kind of more ordered than other kinds of water, and in fact had a gel-like consistency. So the question arose to us, all of this was forgotten because people began, as methods improved, to begin to study molecules instead of ensembles of molecules, and people forgot about the collectivity of water molecules and began looking, the same as in biology, began looking at individual molecules and lost sight of the collection. So we thought, we're going to look at this because we had some idea that it's possible that this missing link, this 4th phase, might actually be the missing link so that we can understand the phenomena regarding water that we don't understand. So we started by looking somewhere between a solid and liquid. And the first experiments that we did to get us going is we took a gel, that's the solid, and we put it next to water. And we added some particles to the water because we had the sense that the particles would show us something. And sure enough, you can see that what happened is that the particles began moving away from the interface between the gel and the water, and they just kept moving and moving and moving, and they wound up stopping at a distance that's, well, roughly the size of one of your hairs. Now that may seem small, but by molecular dimensions, that's practically infinite. It's a huge dimension. So we began studying the properties of this zone, and we called it, for obvious reasons, the exclusion zone, because practically everything you'd put there would get excluded, would get expelled from the zone as it built up, or instead of exclusion zone, EZ for short. And so we found that the kinds of materials that would create or nucleate this kind of zone, not just gels, but we found that practically every water-loving or so-called hydrophilic surface could do exactly that, creating the EZ water. And as the EZ water builds, it would expel all the solutes or particles, whatever, into the bulk water. And we began learning about the properties, and we've spent now quite a few years looking at the properties. And so it looks something like this. You have a material next to water, and these sheets of EZ layers begin to build, and they build and build, and you just keep building up one by one. And so if you look at the structure of each one of these planes, you can see that it's a honeycomb, hexagonal kind of structure, a bit like ice, but not ice. And if you look at it carefully, you can see the molecular structure. So of course it consists of hydrogen and oxygen because it's built from water. But actually, they're not water molecules. if you start counting the number of hydrogens and the number of oxygens, it turns out that it's not H2O. It's actually H3O2. So it is possible that there's water that's not H2O, some phase of water. So we began looking, of course, more into these extremely interesting properties. And what we found is we stuck electrodes into the EZ water because we thought there might be some electrical potential. And it turned out that there's lots of negative charge in that zone. And we used some dyes to seek positive charge, and we found that in the bulk water zone, there was an equal amount of positivity. So what's going on, it looked like, is that next to these interfaces, the water molecule was somehow splitting up into a negative part and the positive part. And the negative part sat right next to the water-loving material, and the positive charges went out beyond that. We found, actually, it's the same. You didn't need a straight interface. You could also have a sphere. So you put a sphere in the water, and any sphere that's suspended in the water develops one of these exclusion zones, EZs around it, with the negative charge. And beyond that is all the positive charge separation. It didn't have to be only a material sphere. In fact, you could put a droplet in there, a water droplet, or in fact, even a bubble. You get the same charge. So the fourth phase, or EZ phase, actually explains quite a lot. It explains, for example, the cloud. And the cloud, it's the positive charge that draws these negatively charged EZ shells together to give you a condensed cloud that you see up in the sky. In terms of the water droplets, the reason that these are sustained on the surface for actually sometimes as long as tens of seconds, and you can see it. If you're in a boat and it's raining, you can sometimes see this on the surface of the lake. These droplets are sustained for some time. The reason they're sustained is that each droplet contains this shell, this EZ shell. And the shell has to be breached in order for the water to coalesce with the water beneath. Now, in terms of the Jesus Christ lizard, the reason the lizard could walk is not because of one single molecular layer, but there are many EZ layers lining the surface, and these are gel-like. They're stiffer than ordinary surfaces. So therefore, you can float a coin on the surface of the water.
A coin can be floated on this fourth phase of water. Again, scale that up to the dome, and I believe it will become the impenetrable dome. I'm going to leave it there, but I will put a full video link in the description box. I'm now going to show a bit more of my earlier vid to support my theory. It is a rocket let loose under some ice to show how similar SpaceX rockets look in the night sky.
Absolutely amazing, and to describe it to you from, I mean, you can see it, but from the ground it almost...
That actually tells me they have managed to get through the impenetrable dome.
Yeah, a lot of this spraying started back after World War II, and the nominal thing is that it is a way of protecting the albedo of the Earth, that by spraying these geoengineered chemicals in the sky, somehow it's going to increase the reflectivity of the Earth, and so much heat won't come in and that. I don't know that I believe that explanation, but that's what they've been giving us, and it's a little strange. I tend to think that maybe what they're spraying is magnetic chaff, and that they want to change the vibrational frequencies that are out, because if it seems like this planet has a poisonous atmosphere, maybe the aliens will attack us. I don't know.
It's a little strange because he can't think of anything that spraying magnetic chaff to change the vibrational frequency is being sprayed for. But I bet it wouldn't be strange if he knew about the firmament being made from the fourth phase of water And these chemtrails are to latch onto the oxygen atoms after being carried up there by the magnetic frequencies that CERN creates. They tried in the 50s and 60s to blow a hole through the firmament. Do you think they gave up? They waited till things was understood more.
Compound in the whole world. 99 out of every 100 molecules is this one. And water is the major thing on everything on this planet. And that should be the ultimate focus of a place where we can clean up and make a significant impact. But now let's talk about those chemtrails which spray out and then diffuse out. And by the fact that I was in the movie What in the World Are They Spraying with Michael Murphy back about 6-7 years ago, I became noted as the resident expert. And the three things we're really worried about are barium, strontium, and aluminum. And actually, the form that they are in the sprays are as the oxides. So we have barium oxide, strontium oxide, aluminum oxide, but notice aluminum oxide is Al2O3. And that's because the aluminum with its 3+ charge has to be balanced to the oxygen with its -2 charge. And so to get these balanced, that's why we need 2 aluminums and 3 oxygens. And this is called alumina, and that's one of the major components of what they're spraying. So why are these 3 the big bad guys? The major component of a biological system is water, but copacetic. Now, magnesium is fairly small. Calcium is about the same size as potassium. Strontium is a little bigger than calcium, and barium is a little bigger than strontium. But you see, if we were to substitute a strontium in for this magnesium, and that's what I think we're doing with the chemtrails, so we put strontium in it. Now, this is a bigger atom than was in it with the atom that belonged. And so because of that, that's going to push this out of whack. This is going to have to be back here, and it's going to start breaking bonds and causing chemistry because you're putting a big molecule in place of something that was smaller, and everything has to spread out to accommodate it. The barium is even bigger than the strontium, and so now you can see when you get a barium into the lattice, first, it displaces a whole lot of things in the lattice. Second, it hangs on better so that you can't get it out of the lattice once it's there. So as where normal chemistry might have calcium substituting in for another calcium, and that'll work for a little while, and then another calcium will come in. Once a strontium or a barium comes into a porphyrin ring, it gets stuck. Now, yes?
Why are those getting substituted? What is it that's allowing? I mean, we're surrounded with all kinds of metals and chemicals all the time. Why are those getting sucked into the ring?
This is an example of how the specific mechanism of a ring was only chosen because it's convenient to talk about. We could easily substitute it onto this molecule down here, in which case we have a calcium which is a lot bigger than a sodium, but here at least it's on the end of the molecule and can get swept off. The real problem with it is that, as I said, these things form as oxides, and they're stable in their charged form as oxides, and so when they stick to an oxygen, they think they're in their normal inorganic place. They're not really ready to go leaving the site they're at, and that's what holds them in, is the fact that the bigger molecules have a more finite attraction for the site than the smaller molecules do, and so the smaller molecules can't knock a bigger one out. Eventually that does happen.
Is that gravity?
Not necessarily. I think it a lot has to do with the size of the fit and the cavity that it's in and how much distortion it caused in a molecule. Because if you twist a molecule and it really is out of shape, the forces to put it back into shape are going to kick that off. But if you just make a subtle change and you make everything loose, what happens is that the components that get loose don't function as reliably, and so your mechanism for doing something like breathing and intaking oxygen might slow down because you've got things cluttering some of your sites because they wouldn't let loose like the molecule was supposed to.